Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use product and chain rules of derivatives to solve this problem. So as per the problem, find the rate of change of each function at the given value of t. So the first function is s at t equals t exponent 1 over 3 times 4t minus 1 exponent 2 over 3, and we have to find the rate of change for this function at t equals 8. Now in this function, there are two functions that are being multiplied. So the first one is t exponent 1 over 3 and the other one is 4t minus 1 exponent 2 over 3. So we have to use product rule to find the derivative of this function. So as per the product rule, so our first step would be, so prime of s at t equals, so the derivative of the first term, so t exponent 1 over 3. So we'll use power rule for that. So it will be 1 over 3 and then t exponent 1 over 3 minus 1 times the second function 4t minus 5 exponent 2 over 3 plus the first function t exponent 1 over 3 times the derivative of the second function. So we'll have to use chain rule because this function has an inner function 4t minus 5 and the outer function which is an exponential function with exponent 2 over 3. So the derivative of the outer function is, so the exponent 2 over 3 comes to the front and the inner function stays the same, and we subtract 1 from exponent times the derivative of the inner function 4t minus 5, which is equal to 4 minus 0. Now we have to find the rate of change for this function at t equals 8. So we do not have to simplify this expression first and then sub in t equals 8. We can just sub in t equals 8 in this step, and that will save us time and steps. So our next step will be, so prime of s at 8 equals, so as we sub in t equals 8, we can also simplify this expression. So we get 1 over 3 and then 8 exponent. So 1 over 3 minus 1 is equal to negative 2 over 3 times 4 times 8 minus 5 exponent 2 over 3 plus 8 exponent 1 over 3 times 2 over 3 times 4 times 8 minus 5 and then exponent 2 over 3 minus 1 is equal to negative 1 over 3, then times 4, because 4 minus 0 is just equal to 4. Now in the next step we can simplify it further. So prime of s at 8, so equals 1 over 3. Now since 8 has a negative exponent, we can move it to the denominator with 3, and that will make the exponent positive times, so 4 times 8 is 32 and 32 minus 5 is 27, so we get 27 exponent 2 over 3 plus, now 8 exponent 1 over 3 is equal to 2, so 2 times, now 2 over 3 can be multiplied to this 4, so we get 8 over 3 times, now 4 times 8 is 32 and 32 minus 5 is 27, and 27 exponent negative 1 over 3. Now in the next step we can simplify it further. So prime of s at 8 equals 1 over 3. Now 8 exponent 2 over 3 can be simplified to 2 squared, which is equal to 4, times, now 27 exponent 2 over 3 can be reduced to 3 squared, which is equal to 9. And now plus, now 2 times 8 over 3 is 16 over 3, and we can move 27 to the denominator because its exponent is negative. So we get 27 exponent 1 over 3. Now we can simplify this further. So we get prime of s at 8 equals, so 1 over 3 times 4. So 3 times 4 is 12. And so 1 over 12 times 9 will be 9 over 12 plus, and 16 over 3, and then 27 exponent 1 over 3 is 3. So it's basically cube root of 27. So now we can simplify it further. So prime of s at 8 equals 9 over 12, which can be reduced to 3 over 4 plus 16 over 9. Now we have to add these fractions. So we have to find a common denominator, and the common denominator is 36. So we'll multiply the first fraction in the numerator and the denominator by 9. So we get 27 over 36, and we multiply the second fraction by 4. So 16 times 4, which is equal to 64 over, and the denominator will be 36 because 9 times 4 is 36. Now we can combine the two fractions. So 27 plus 64 is equal to 91. So the final answer is, so prime of s at 8 is equal to 91 over 36. So now we can analyze the second function. Now this second function is in the form of a fraction, and the exponent 1 over 3 applies to both the numerator and the denominator. So the first step here is to split up this exponent and apply it to both the numerator and the denominator separately, and then move the denominator to the numerator so that we can use product rule. So first let's simplify this function. So s at t equals, so in the numerator we get t minus pi exponent 1 over 3 over t minus 6 pi exponent 1 over 3. Now we can move this denominator to the numerator. So we get s at t equals t minus pi exponent 1 over 3 times t minus 6 pi exponent negative 1 over 3. Now we can use the product rule to find the derivative of this function. So we get, so prime of s at t equals, so the derivative of the first function, so we'll have to use the chain rule here. So t minus pi is the inner function, and the outer function is the exponential function with the exponent 1 over 3. So we start with the derivative of the outer function. So 1 over 3, so the exponent comes to the front, times t minus pi, and then exponent 1 over 3 minus 1, times the derivative of the inner function, which will be 1 minus 0, times the second function. So t minus 6 pi exponent negative 1 over 3 plus now the first function, so t minus pi exponent 1 over 3 times the derivative of the second function. So we'll have to use chain rule again. So we'll start with the outer function, so negative 1 over 3 times t minus 6 pi exponent negative 1 over 3 minus 1 times the derivative of the inner function, so that will be 1 minus 0. Because 6 pi is a constant, so the derivative is equal to 0. Now we have to find the rate of change at t equals 2 pi. So in the next step, we can sub in t as 2 pi. So prime of s at 2 pi, and we can also simplify this expression. So 1 over 3 and then 2 minus pi exponent. So 1 over 3 minus 1 is negative 2 over 3. Now 1 minus 0 is just 1, so multiplication by 1 doesn't change anything. And in the next parentheses, we'll sub in t as 2 pi minus 6 pi and then exponent negative 1 over 3 plus, now again 2 pi minus pi exponent 1 over 3 times negative 1 over 3 times now 2 pi minus 6 pi exponent. So now negative 1 over 3 minus 1 is equal to negative 4 over 3. And then 1 minus 0 is equal to 1, and multiplication by 1 doesn't change anything, so it goes away. Now we can simplify it further. So prime of s at 2 pi equals 1 over 3 and then pi exponent negative 2 over 3 then times negative 4 pi and then exponent negative 1 over 3 plus, now we get pi exponent 1 over 3 and then negative 1 over 3 and then times negative 4 pi and then exponent negative 4 over 3. Now we can simplify it further. Now in the first part, so pi and negative 4 pi have negative exponents, so we can move them to the denominator. So prime of s at 2 pi equals 1 over 3 and then pi exponent over 3 and then negative 4 pi exponent 1 over 3. Now in the next part, so we have this negative 1 over 3, so we get negative, and then see pi has a positive exponent 1 over 3, so it will stay in the numerator, so pi exponent 1 over 3, and the 3 and 4 pi terms, negative 4 pi terms can be moved to the denominator, so we'll get 3 and then negative 4 pi and then exponent 4 over 3. So this can be the final answer for the derivative of this second function at t equals 2 pi. Now we can simplify this expression further, but that will require a lot of steps and your teacher may not want you to simplify it any further. So these are the steps you have to keep in mind to find the derivative of these types of functions. So for these types of functions, we have to use product and chain rules together to find the derivative. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.